we're going to define theta. So theta is a measure of the effect of the time change on the bond price. So if we have that the PV of a certain cash flow KT, it's equal to KT e to the minus RT, then the theta is going to be the derivative of this PV with respect to time. And this is going to be equal to minus the interest rate, KT e to the minus RT, which is the same thing that R times the PV of KT. So here we write the theta, dollar, that's how we're going to call it in this class, and it's going to be equal to R. The dot is to indicate that it's in continuous compounding. That's why I defined my PV in terms of continuous compounding rates. And we're going to have that if you have several cash flows, it's going to be R1 times the PV K1 to get your first theta, and so on for all the maturities that you have. Now, this is going to give us an improved approximation of the price change in the bond when you have a small change in time. So the change in price, now it's going to add this extra term, the minus theta times the change in time. Let's look at an example of how you compute your theta. So this is again our 3-year bond with semi-annual coupons and a coupon yield of 14%, that it's annual, and a face value of 100. It has semi-annual payments. So the first thing that you have to do in order to be able to compute your theta is that you need to get your interest rates. So how do you do it? If you have the discount factor at time t, then you know that this is equal to d to the minus rt times t. And then from this, you take logarithms on both sides. So you end up with log of dt equal to minus rt times t. And then from this, you end up getting that rt is equal to minus logarithm dt over t. That's how I got my continually compounded interest rates of 10%. Then the only thing you have to do is multiply this r times the PV and you get your theta. You add them up and you get a theta for this bond of 109.4677. So now let's imagine that time changes. So right now, all times are going to be reduced by 0.25. So let's say they're going to go from 3 to 2.75. So then the change in price can be approximated by minus theta dollar times the change in time. So this is going to be equal to minus 109.4677 times the change in price, which would be 2.5 minus 3. And then this gives me that the change in price when the time is reduced by 3 months or 0.25 years is 27.367.